So today's talk, we are going to invite one of the young scientists from Singapore. So let's invite him and then we'll start the show. So let me invite him. Hi.
Hello, guys.
So welcome to our show. I'm very happy that you agreed to come to this show and share
Thank
your
you. Thank you for
thoughts.
inviting me.
Yeah.
Yeah, thank you for inviting me on the show. It's an
Uh,
honor to be on the first episode of the show.
yeah, I'm very happy and very delighted that you came. So
Yeah.
viewers, let me give you a brief introduction about our speaker, and then we can, jump start the show. So today's speaker is Dr. Kashyap, and the topic he's going to talk about is Earth observation from space. It's rocket science, and about his background. So he did his bachelor in engineering from aerospace engineering at University of Liverpool, UK, and then he did his double masters in science from space technology at Luleå Technology University, Sweden, and Czech Technical University, Czech Republic. So he did dual masters in that, and then he did his PhD from Singapore. So he did PhD in remote sensing and atmospheric science at Nanyang Technological University. So I had a privilege to work with him, and he used to be our colleagues and a co-worker when I was in Singapore, and I had an opportunity to work and discuss science with him. So I'm very happy that you came to give a talk on our show.
I'm very happy
So
to be here.
yeah, okay. So let's start today's topic. So before we start today's talk, I would like to know that how your journey started, how you decided to become a researcher, what motivated you to become a scientist, how the journey started. So tell me something about it.
I mean, when we were young, right? So, scientist is something that is a very far away thing for us. We never think of becoming a scientist. So, for me, it started after my master's. I was looking for jobs, preferably in satellite space science related areas. And my sister actually asked me, why don't I do a PhD? Why am I just looking at for jobs? So
Mhm.
then I thought about research, like like am I even interested in doing research, or like it's a big thing. Like research is something not everybody is fit to do. Like it's not a uh, easy thing to accept that you can do research. So for me, it was not like I never thought that I would be a researcher
Mhm.
because I didn't think that I had the mind to do research. And
Okay.
then I thought about it. I applied for PhD and I came to Singapore. Even after coming to Singapore, I still didn't believe that I have mind to do research, even while I was doing research.
Mhm.
So it is interesting for me because I was interested in the topic rather than like idea of becoming a scientist. I just wanted to work on this space science or satellite related topic.
Mhm.
So that is what actually motivated me to be in this field of research. And of course, once you come into the field, you know about the problems, and some problems attract you more than others, and then you want to solve them, and that is how I'm into doing research.
Okay,
So
great.
yeah,
Yeah, so it was nice story and happy to know that. And
yeah,
I'm very sure that many people, many student will relate to it, and they will also get inspired and consider themselves that if they want to do research, they can do research even if they don't know much about it. Slowly they will get
yeah,
exposure, and it's not something very extraordinary as it seems for students to be. So
yeah,
it's
yeah. That's
yeah,
the
same like
that's the
when you
idea
do
that I want to
same
give.
like yeah, yeah,
Yeah,
true. So it's not something which is not which cannot be achieved. Definitely, if you want to become a researcher, you can do it if you have right exposure and you have curiosity, you have question in your mind, and you want to chase that question. So I think definitely
yeah.
you can be a researcher.
y- we hear this thing ever since we are young that, oh, scientist is something that is a very far-fetched dream for many people. So I want to like now I'm a scientist and I can still say that it is not that far-fetched because I am a scientist now. And to be honest, I'm not really that smart. So
No, you are. You
yeah.
are. I know, and you are humble to say that. Okay, so so let's jump into the today's topic. Uh, could you just explain briefly that what we are going to talk about? What is the satellite, and some basics about satellite, so that we get a sense of understanding of satellite before we jump into some more detail about it.
Yeah, okay. So before I start my presentation, I will just give a brief introduction. We all know about satellites these days. We read in newspapers, we see in news, we see on YouTube, like, of course, SpaceX, NASA, ISRO, European Space Agency. We hear about all these things all the time that they have sent this satellite to space, they have found this thing on Mars, or they have found this thing on Venus or Moon or something. But it's like in this talk, we can step into this field and see. Uh, we always see like these things happening, but why don't we dig a bit deeper and see how these things actually happen?
Okay.
So I'll just share my screen.
Okay.
Um, okay, can you see?
Let me quickly add it. Okay.
Yeah. S- So here, what is a satellite? To be honest, so satellite is any object that any celestial object that revolves around a larger object is called satellite. So, for example, Moon is a satellite for Earth. So, Moon is a smaller celestial object that revolves around the Earth. So, this is the official definition by NASA. So let's say we Earth revolves around the sun. So in an essence, Earth is a satellite of the sun. So we in our satellite field of industry, so we have now we make artificial satellites so that we can monitor the Earth from space. So why do we need to do this? Because once we have eyes so far above the Earth, we can see larger area that we cannot really see from where we are. So that's the main objective. So going one step further, so let me just give a quick introduction. Like the first ever artificial satellite was made in 1957 by Russia. It was called Sputnik. It weighed roughly around 80 kilograms, lasted 22 days. So all these 22 days, it was just transmitting radio pulses until the battery ran out. So the radio pulses where we receive them on the ground and we know that the satellite is alive. And after 22 days, it started to re-enter the atmosphere. So what we call re-entry means the satellite comes back into the atmosphere from its orbit. So the terms orbit and re-entry, I will talk about more in detail later. So once it re-enters the atmosphere, it completely burns up. Uh, if it doesn't burn up, it will we target it and plan it so that it lands in the sea rather than ground and hurting somebody. So that's how we calculate these things, and the orbit trajectories are calculated in that way. So just to give you an idea, so how high does the satellite fly? So it flies very far away, we know that, but to give a rough estimate in a relative scale, so I give you like, okay, the Burj Khalifa Tower in Dubai is 828 meters. Mount Everest is 10 times higher than that, so around 8 kilometers. Any cargo airplane like Airbus A380 flies around 13 kilometers, so cargo or passenger aircraft. Military aircrafts fly a bit higher than this. And we have stratospheric airships that fly from 19 to 21 kilometers. And we also have high altitude balloons. So we launch balloons to study weather in stratosphere. So that can go up to 37 kilometers. It cannot go beyond that. And then we have our first satellite, the International Space Station. You guys must have seen this International Space Station in many movies like Interstellar or Martian or some other. A lot of American movies have this International Space Station in them. So
Gravity,
that,
I think.
yeah, Ajit, what?
Yeah, gravity, I think.
Yeah, Gravity also.
Yeah,
And so this flies around 330 to 400 kilometers. Why it doesn't go around at the same altitude? It's because it flies in an elliptical orbit, not circular. So I will just come through those things after this. So, and then a typical low Earth orbit satellite flies around 800 kilometers. So, low Earth orbit, why low Earth orbit? So, the atmosphere, Earth's atmosphere starts from roughly around 2 kilometers and it goes all the way up to 2000 kilometers. And we can have our satellites flying in these regions and even beyond that. So just to give you an estimate of what these things might look like, here is Earth. Low Earth orbit is something we call if a satellite flies until 900 kilometers. So you see the International Space Station flies at 400 kilometers. And then we have sun synchronous satellites. That means these are the satellites that looks at the sun all the time. Although it is revolving around the Earth, the it always faces the sun. And then we have medium Earth orbit. So that starts from 900 until 2000 kilometers. And anything above 2000 kilometers is called high Earth orbit satellites. So you guys must have heard the GPS satellites. So GPS flies around 20,000 kilometers or 21,000 kilometers. That's like very far away from Earth. Why we need to send it so far away? So that it can have continuous signals with the earth and with each other without any direct contact with the earth. So it needs to be far away enough so that it can avoid the earth interruption. And then we have geosynchronous satellites. Geosynchronous satellites basically mean it will be above a certain point on earth all the time. So let's say we are above Singapore right now, and the satellite, if we can look at the satellite above Singapore, so we will be looking at the satellite all the time. So that means it has to be very high so that it can have enough speed to do this. So that basically is around 36,000 kilometers above the Earth. So this there are a lot of numbers here, and it is hard to imagine these things. So which is fine. I mean, we don't have to imagine how far a satellite really flies because we cannot really see them. So this is just to give you an idea about what kind of orbits we have, and depending on what we want to do, the application, we launch those satellites in different orbits. So any questions, Ajit, so far?
okay, so yeah, that's pretty interesting. And for me also, I mean, I was not very aware of the fact that how far space is. Like when we talk about space, or when we talk about, I mean, all those space programs, I didn't have that perspective that how far exactly it is when we say someone went to space and, doing some work in space. So pretty
Yeah.
much interesting information you provided us. So now, after understanding what the satellite is and where it is, could you tell me about why we what we use satellite for? Like, what are the uses? What are the purposes of using satellite for?
Yeah, so satellite is something that we can use for many different purposes. So because we can look at the Earth from such a far away distance, right? So the first thing that comes into our mind is imaging the Earth. We all want to see how beautiful the Earth really looks from outer space. We keep studying this term for Earth called it's a blue planet. Blue planet. Why is it blue? How do we even know that it's blue? So those are the things that we can actually see the Earth that is blue because it's a lot of water in the Earth, surrounded by the water, and the land mass is only 30%. So when we look at the Earth from the space, we see it as a blue planet because of the water. But of course, other than the just the beauty of the Earth, we all use Google Maps these days to go from one place to another. So Google Maps are mainly constructed using satellite images taken by uh, space. So I show you three different images here of three different places. So we can have we can see how clearly we can see the boundaries of land and ocean. And some of the images we can get are very high resolution images. Some of the very expensive satellite images are can reach up to resolutions of 30 centimeters. So you can imagine that a satellite that is flying 800 kilometers or even 30,000 kilometers away from the Earth can have cameras which can give you 30 centimeters of resolution. So that is something which is truly amazing. And one of the things that is interesting enough for people to get curious, like, oh, what kind of cameras they actually use to get that kind of resolution from so far away. So this imaging is something that is the most fundamental application of the satellite. And of course, the other uh, application is communication and navigation. So after the Earth imaging, the most common use of satellite is for communication. So we have geosynchronous satellites and GPS satellites. They are all, in an essence, like communication satellites. They transmit signals constantly so that our mobile um, broadband network providers or TV broadband network providers, they all tap into these signals so that they can use these signals to uh, for us to have entertainment. So, for as a communication satellite, its main job is to relay information from one place to another. So, let's say we have Hubble telescope, which looks at many different celestial objects with its very uh, strong telescopic features. So it gets the data from this satellite and it gets data from, let's say, International Space Station. And it is something that can have contact with this particular ground station on Earth all the time. So that these satellites don't have to directly talk to the ground station. They can keep doing their job in space, looking at the space and collecting data, and they can just send the data to this communication satellite and it can just send it to the ground. So this way we can optimize our functionality of satellites so that every satellite doesn't have to have large data transfer ability. And of course, then we know about the GPS. We all have GPS in our phones. So this is something called global positioning system. So there are roughly around 36 satellites in orbit, uh, constantly orbiting the Earth. So we have signals from this constantly transmitted towards the Earth. So our phones or any other GPS receiver can receive these signals, and if it can look at any four satellites at a time, then it can know its own position. So the GPS is basically designed to give a user his own position. So that is something that is revolutionized the industry in 1970s when they launched the GPS satellites, and everybody can be tracked nowadays. So so that is something very interesting.
Okay.
And the final uh, application of the satellite is the weather. So we all know that cyclones and hurricanes and other disasters such as earthquakes, we get hit by this all the time. So satellite data is something that can see these things develop when they are still far away from the civilization, and we can have advanced warning because of this. So such as seen from this particular image in the top left. So you see a hurricane developing here, approaching towards the land. So if we have this kind of information, then the weather forecast people can see these things and they can alert those areas that okay, you need to evacuate, or because of the cyclone or hurricane approaching this place. So that is something that we use very frequently in our weather prediction systems. And other features we can do is land imaging. Apart from the 2D imaging, we can have radars and lidars which can image the land, such as seen like this. So we can have two satellites imaging the same place at the same time or at different times. So we can use those signals to generate 3D maps of the Earth. So 3D mapping is something that has been uh, quite famous or most used like in last 2 decades, let's say. A lot of people have been using these things to map 3D and see how uh, the land height or the topology of the land changes. And this final image I'm showing is from a radar, also the satellite radar. So what this radar does is it detects the clouds. So clouds is something that is very important to us as a in weather prediction. So what happens is clouds are very key role players in heat trapping. So if there are not enough clouds, all the heat that land absorbs during the night, it just lets go. So it just goes back into the space. So clouds are very important so that we retain those heat so that we can survive on this surface. So this cloud satellite basically detects the clouds. So you can see there is a cyclone developing here just like this, and this satellite can probe into the cyclone basically to see the vertical profile. So this is very useful also when it comes to weather prediction about the extreme weather. What extreme weather is something we see as thunderstorms or cyclones or hurricanes. So these things are very useful to and useful tools to see from a space perspective, because we can see much larger area compared to what we can see from the Earth. So one of the biggest advantages of using satellites is how much area you can actually cover. So that's the thing we want to see, right? That's mean from land we can only see something that above or 30-40 kilometers only. With a satellite, we can cover thousands of kilometers just in few seconds. So that is something that drives the satellite industry to keep thriving. So that is the end of the applications I have so far.
Okay, so yeah, it's pretty interesting to know about how and where we use satellite. And yes, there are multiple application of satellite. We use the use of satellite is on day-to-day basis, as you
Yeah,
mentioned, that including GPS, including satellite TV, and many more weather prediction, all of those kind of stuff. So definitely, it's one of the important asset we have these days.
yeah, yeah,
So after understanding that what satellite is and how what where we use satellite for, could you please explain a little bit that how we send satellite to space, like how we manage to send satellite to a particular orbit and how it's done?
yeah, sure. So just before I talk about the launch of the satellite itself, I would briefly talk about how the satellite is, what satellite has basically to do
Okay.
all these things.
Yeah, that's a good point.
So
Yeah.
yeah, so there are typical systems in a satellite. So basically, a satellite, as you see here, has solar panels. So nowadays we hear everything is about solar powered, right? We want to use solar power so that we can have conservation of energy because we are running out of resources. So in space, we don't really use resources from the Earth. To satellite is still a system of electronics, right? All the electrical systems need to be powered, just like TV, laptop. It needs a power source. So where do we actually get the electrical power from? So we have solar panels that look at the sun, and we can generate enough power, and we can store it in the batteries so that all our electronics can work as it needs to work. So, and then we can say, oh, the satellite is constantly revolving, right? It is not looking at the sun all the time. So, of course, that's why we need batteries so that uh, once we charge our batteries enough, it can go on the other side where we don't look at the sun anymore. Then we can just use those batteries to power our electronics. And then the satellite comes back to the sun facing side and we can recharge our batteries. So that is something very typical power system in a satellite. And then we have a thermal system. Thermal system is something very interesting to talk about because in space, what is not known to a lot of viewers, maybe not known to a lot of viewers here, is extreme temperatures that we face in the space. So basically, when the side that is looking at the sun, it is receiving the heat from the sun constantly. So it is very easy for that side to get very hot. And the side that is not looking at the sun, it in space it is not, there is no conservation of heat, so this side gets extremely cold, although it is just on this side of the other side of the side which is facing sun, the the far side gets very cold because of no radiation being received. So these are the harsh conditions that the satellites face in the space. So we need a thermal system which can control and optimize the functionality of the satellite so that all the systems are maintained in the operational range. When I say operational range, meaning all the electronics have operational temperature range. So if these electronics are exposed beyond this temperature range, it will stop working. So we need to maintain certain temperature inside the satellite, regardless of which face is facing the sun or the deep space. So then the third one is the control system. So the control system is something that lets us. So let me just quickly go out of the view so that I can use this. So control system, let's say we want the satellite to turn here and take a picture, or we want the satellite to move. So these are like satellites will have propulsions or like wheels that rotate so that it can do all the rotation. So we can point the antenna towards the earth and do the communication and something similar. So that is called control system of the satellite. So that is something very crucial to design very accurately, because sometimes we want to look at something very precise, like we want to say, okay, let's point towards some particular building and take the picture. So the satellite needs to know where it needs to turn and it needs to take the picture. And after that, of course, we are collecting all this information from the payloads, the control system, everything we need to transfer back to the earth, because all the images we take, we need to send it back to the earth, or else we cannot see them. Or any other information such as radar, we need to send it back to the earth. So then we need a communication system. So let's say this antenna is part of that communication system. It will do the um, transmission of all the signals that has the data, and then we get them. So last but not least, every satellite has a computer on board. So the interesting thing about the satellite is it has to do everything autonomously. So unlike land systems where if something is wrong, we can go and reprogram or something, satellite it is not as easy to do those things because we cannot touch it. It's very far in space. So these systems need to have a software which controls everything, and this software runs on a computer called onboard computer. So this needs to be a very good computer, very highly reliable computer, so that there are no errors in any of these functionality. So these are the typical systems inside a satellite. Now, as Ajit asked, like, okay, what does satellite require? So it requires a rocket. So the satellite cannot go by itself in space because to reach the space we need a lot of speed, we need a lot of energy to put the satellite into the orbit. So that machine that which does that is a rocket. We also can call it launcher. So that can put the satellite into the orbit. And of course, once it's in the orbit, it is doing all this functionality and it needs to send all the data back to the Earth. So that means we need a station at the Earth to receive all this data. So that we call a ground station. So a ground station typically is a very powerful antenna system with a backend for all the communication receiving system. So that we can receive and process all these data. So here I just have a quick video about the satellite launch. So this is from a ISRO satellite, Polar Satellite Launch Vehicle (PSLV). So you see the amount of fire that is being exhausted from the exhaust of the satellite. So the satellites goes roughly around. Sorry, the rocket goes roughly around 8 kilometers per second, and to for it to even reach the orbit, it needs to go all the way until 11 kilometers per second so that it can escape the Earth's gravity. That is called escape velocity. So for Earth's gravity, it is 11 kilometers per second. For different planets, it can be different. So that is something very interesting to see. I myself want to see a rocket launch once in my life. It is interesting to see Ajit because the amount of fire that comes out of the rocket is in such a huge scale that we need to stand 3 kilometers away from the rocket for us to be safe.
Yeah,
So
I have seen a couple of videos, but getting that real perspective of, the size of the rocket and how far you have to stand and how much fire it produces, unless you go and see it, you will not get that sense. So I'll
yeah,
be
yeah,
very
you
happy to
see
see someday.
the.
Yeah,
I'll just replay the video. You see the amount of fire. It is an explosion basically. So you normal people need to be like very far away from the actual launch station. So it is an interesting thing to see, and I hope I will get to see a
yeah.
rocket launch
So
once in my life.
yeah, so just to add that, so there are a couple of NASA, launch space center here, and I'm also planning to, see, go closer and see, not that close, like, if there is any launch happening in near future, I'll try to go and see because there are a couple of, launch stations here in US. So let's
Yeah,
see when I
yeah,
get a chance to see, but it'll be pretty interesting to, to
yeah,
see that.
yeah.
Yeah.
It's definitely an event that cannot be replicated by any other event.
Yep. 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 True.
Yeah. So so the next thing I think we can talk about is, I mean, we covered what the satellite is made of and how we launch into space, right?
So one thing our viewers would like to know that so what are the challenges you guys face when you do research in this field? Like how you test your satellite, what like, because we already know that there are already many satellites. So what kind of advancement you want to achieve, or what kind of research you guys do in this field? So if you give some light on that, area, it
Yeah.
will be helpful to know. Yeah.
So yeah, before I get into the uh, actual research or the latest technologies that are happening, I can briefly show you the basic testing facilities that a satellite needs to have. Because once we put everything in a satellite and send it to space, we cannot really bring it back. And if there is something wrong, we cannot really bring it back and fix
True.
things right as we do for other things on Earth. So we need to do a very rigorous testing for all the systems that go into the satellite. So one of the pictures here, so you see there are a lot of electronics board here, right? So these are the electronics board that represent different systems. So before putting this into a satellite structure, we put it on a table like this, and we test that whether everything from hardware, cables to software is working exactly as how we expect it to work. And we test it over and over again for several months. So these tests go on for like more than 6 months. And in some of the bigger satellites can go on up to a year. So these are the things we test rigorously, so that we don't want any errors to happen when the satellite is in space, because we cannot really bring it back anymore. So this setup is called a flat sat. So that means a flat satellite. The satellite is laid out in a flat table and we test it. So of course, other than this, we test our individual systems separately, like an onboard computer or the software that is written. We test it rigorously so that we try to put the software through a lot of tasks, so that if there is any error, we need to know those errors. And other than that, of course, there are solar panel tests. Solar panel tests are quite interesting because we have a solar simulator and or a sun simulator to be more precise. So it's a light source, basically very intense light source. So we put that light on the solar panels to see whether it is generating enough power that we expect it to generate. And this light source is so intense that it can literally blind a person if he look directly into that light. So we need to be very cautious about these kind of experiments. Uh, so we play with our lives every day, man.
Yeah, that's pretty intensive. Yeah.
And
So,
another
so just
thing,
just quickly a
yeah,
quick question. So these are the pictures you are showing, is some of them from the experiment you guys do in your lab?
yeah. So these are the pictures in taken. Some of the pictures are taken from our lab. Some of the
Okay.
pictures I took it from the facilities. We don't have, but we go to the place where we do those tests.
Okay. Okay. So these are like real,
Yeah,
real
these are
real
the
pictures showing how exactly you guys work. Do your
yeah.
job and make satellites. Okay. Interesting. Yep.
Yeah, yeah. So talking about another life in danger test is called the anechoic chamber test. So basically, what this is, we test our antennas here. So that means electromagnetic radiation. We need to test whether our antennas are giving enough power in the direction we want it to give. So this is a chamber that is called anechoic chamber, meaning there will be no echo in this chamber. So meaning echo is something a reflection, right? So the walls you see here is are structures that basically absorb every frequency or every electromagnetic signal that hits it, so that nothing comes back. So when you put an antenna in such a chamber, you can exactly measure what the power coming out of the antenna without getting all these extra reflections that we get all the time, so that we can precisely test our antennas in this case. So And apart from that, just we just saw a video of rocket, right? There is insane amount of exhaust power coming out of it. There is a lot of vibration. There is a lot of shock. So we need to test whether our satellite can even withstand this kind of shock, and we need to test whether we our satellite can withstand uh, the space environment, basically the harsh temperature differences we talked about earlier. So we have all these chambers you see here. So these kind of chambers are where we test our structures. Basically, this thing here, basically, it gives it a vibration so that the vibration is enough so that it can simulate what the satellite is going to face in the rocket. And then these are the chambers where we can control the temperature that the satellite is going to face in the space. So we put the satellite inside the structure, we close the thing, and we cycle it over and over again so that we can know that our satellite can definitely work in this kind of environment. So these are the test facilities that we build so that we can make sure the satellite works exactly as we want it to work. So, any questions about this?
So we'll take questions at the end of talk, maybe.
Yeah, sure.
Okay. Yeah.
So
There are a couple of
now,
questions people are asking, so but we'll take them at the end of the talk so that we go uninterrupted.
yeah, sure. So now we can go towards the latest research. So one of the things that we always face one question is like satellite is an expensive affair, right? Every satellite is $1 million, few $1 million projects, at least even the smallest ones. And of course rockets itself are like several tens of millions of dollars. So every time previously they would launch a rocket and the rocket would just be a one time use and it will just fall into a sea or something, and that's it. So that's a very expensive affair. So what scientists recently have been working towards is reuse of the launch vehicle. So SpaceX recently uh, demonstrated this. So this was in 2018. I will just quickly go through the video here. So they have this is called Falcon Heavy launch vehicle from SpaceX. So you can see that this video is a promotional video for them. So a lot of people watching this. The rocket basically lifts off, goes into the space. So this is not the highlight of this video. The highlight of this video is, of course, it this rocket launched something. In this case, it's a car. The
Eh,
car is orbiting the Earth. Then the rockets now have to come back to Earth instead of getting wasted. So you see, they are coming back. Uh, they maneuver themselves so that they can come back to the location they need to be in. You see the white. Now you see this fire is from the re-entry fire, and now they have slowly started to control it. See, the rockets are coming back very controlled, and now it is actually landing back. So this is a technology which can help us to reuse rockets again and again, because it's a waste so that we only use the rockets once, and it is a very expensive thing. So this technology has really revolutionized the industry now. So a lot of people will start to use this technology.
So
And
just to add to it is I think recently SpaceX has also sent astronaut to space using the same technology, I guess, because
yeah,
the
yeah,
rocket
that was
came back and yeah, they were able to reuse the rocket. So rocket came back successfully on Earth, and the astronaut were able to go to the space. And then after like few days, they stayed in space station, and then they came back successfully. So that was one of the big,
yeah, a few
I mean,
months ago
history
it
was
was a
made,
big
and
news.
it was,
Yeah, yeah,
yeah.
yeah, yeah. So these are the things that I think large scale, uh, how do you say, like large scale goals in this satellite industry. So that these are like very, this basically revolutionizes the industry. And and I mean, there is this thing, and then let's look at another side of the industry, which is the sad part of the industry. As you can see here, there are tons and tons of satellites here. So Earth looks like this. So this field of research is called space debris. So there are so many satellites around the Earth, revolving around the Earth, and this is just a near view. You can see the far view. There are many satellites around the Earth doing all kinds of things, and a lot of satellites are not even working anymore. So that means it's effectively a space junk. So, and there are other things other than satellite, like one astronaut lost his glove, and that is just orbiting around the Earth. And this can go and hit things and cause damage. And as you know, I mean, one in space, things are traveling very fast because there is no air resistance.
Yeah.
So,
So yeah,
so
I
this
just
glove is
interrupting
this
you.
glove is traveling at 28,000 kilometers per hour. So if it hits something, it can really damage something.
Yeah, just
So,
interrupting you. So I remember
mm,
recently also in
yeah,
space, there was some spacewalk or astronaut was doing, and he lost his tools, and he was
yeah,
not able to catch it. And there was a lot of buzz about it that
yeah.
because it was not attached or something to the space station, and before he was able to grab it, it just vanished, and it will be revolving around the Earth for forever, right?
Yeah,
It will be
forever, because these are the things that are very small, and it is hard for it to fall back into the earth, or it is hard for it to, like, since it cannot come back into the earth, it cannot burn up, so it will be in space forever. So these are the things that a lot of people are actually are trying to build satellites for this, which can go and collect the junk in space. So that satellite will be dedicated to do this. So you see, there are few cases where some satellites crashed with each other, and then there will be, from the collision itself, there are a lot of particles like this. So these are the things that can go and crash into other satellites and cause damage also. So there are some research going on of how to deal with these things. Of course, it's not something that can happen very soon, but people are researching on this actively. And other than this, uh, not minor, but small scale research is miniaturization of everything, like all the circuit boards and everything we want to miniaturize so that the satellites can be smaller and smaller, just like our laptops or phones or something, but do equal amount of work as big satellites. And the other crucial research area is the radiation hardened components. So radiation hardened components is something, in space we have a lot of ions. So what we call plasma, right? They are like charged particles everywhere in space coming from sun. It charges all the particles in space because of the magnetic field and the amount of velocity they travel with. They have very high kinetic energy, so they constantly bump into the satellites, right? So these can actually harm our electronic components. So what this research basically does is radiation harden. That means even if it hits the electronic components, our electronic components will still be functioning properly. So that is something, a very active research area since, I think, last 3 or 4 decades, and we keep improving our components for this. And then, of course, then there are higher frequencies for high data rate communication. These days, everything is about more data, right? We want higher speed internet, bigger images, higher resolution images being downloaded from space. So for sending such high data, we need very high frequency to support that high data. So that means, no, the communication lines have to be very uh, effective and very efficient. and it's in space, so that a lot of things can go wrong in space. So communication is something that is also a very active area of research, so that it can support a higher frequency of communication. So these are the summary of active research areas or large scale developments in satellites. So that's all I have for today, Ajit.
Okay, so that was
Yeah.
very interesting, and for me also, after spending a couple of years in research in biology, I was like maybe 20% I knew about what you explained. So there was a lot of enlightenment for me also, and I'm very sure that all our viewers might have learned a lot of thing, and there is many take home messages from your talk. So we'll try to quickly take some of the questions, which there are many questions people have asked. I'm very thankful to them. They're spending time on watching this live, and they're asking very interesting questions. So I'll try to take some of them, and
Yeah.
I'd like to have a very quick comment on them because there are many of questions which has been asked. So let's see. So Sweta Sinha, she's asking,
Mhm.
let me show it on the screen. So she's asking that could you talk about the need to have manned or unmanned satellite?
Could you talk about, okay, manned or unmanned satellite? So, sending people in space is a very risky business. So, I just talked about how many tests we really have to do just to send bunch of electronics in space, right? And sending a human in space is we have to be very careful about what is the purpose. And a lot of astronauts do go to International Space Station. So we hear about all the people going to International Space Station, but it is a like, but then we also hear these kind of news where astronaut lost something, or there was a air leak in the International Space Station. Few weeks ago, there was an air leak in the space station. So you can imagine having an air leak in the space stations, meaning the astronauts might die from not having air. So those are the things that we really need to think about, and whether we can justify sending a human instead of electronics. If we can justify, of course, there is we can send manned satellites to different locations.
Okay, so yeah, just to add that because I mean people have been trying to go to space for a long period of time, and there are several casualties we already know which happen because we are risking life of someone when we send someone in space. So it has to be a very high priority project, which cannot be done if we cannot send a man to do that. Uh,
Yeah,
to do that. So if we can send robot or anything else to do that, I think we prefer to do that instead of sending someone risking their lives. So we'll take
yeah,
very couple of other questions. So there is another question. I'll just try to put that here. So
yeah,
Om Prakash is asking, can satellite be used in real-time monitoring to check any infiltration on the border? That's a good question. That
yeah.
if from
That's a good question. There was a recent movie about it. I mean, it's not a recent work, but people have used, not in real time, but they have used satellite to check infiltration in the borders. But answering the question, if we have geostationary satellites that can look at the same position all the time, then we can use real time monitoring from the satellite. Because if you want to monitor something all the time, then means satellite has to be on top of that location all the time. So that can only be done by geostationary satellites. But the interesting thing people can ask, oh, why don't we just launch geostationary satellites? Because the way the satellite law works, because of the optimization of space, geostationary satellites are very far away. So it can have a very broad view of the Earth. So the neighboring countries can also uh, share the same satellite, or it's like the law basically works like for a fixed area of a country, only one satellite will be allowed. So for example, a country as big as United States, of America, they can have few different geostationary satellites. For a country of size of India, we can have 3 to 4 maybe. But a country of size of Singapore, it cannot have any satellite which is geostationary because it's too small. It needs to share its geostationary satellite with others. So Singapore has one geostationary satellite which it shares with Taiwan. So it needs to be done something like that. But if you want like monitoring something constantly, that is the way to go.
Okay, so yeah, that's nice answer. We'll take few more questions real quick.
Yeah.
Let me see the next question. So Shivam Chauhan is asking, can you please throw some light about the type of energy storage system used in satellite? So I think,
Currently,
hmm,
most satellites they just use batteries. So it's the only way of storing energy for now. There have been some active research going on where they have been trying to store energy. Satellite electronics itself they produce a lot of heat because just like our laptops, when we run electronics for a long time, there is heat, right? So they try to harvest this heat and then they try to convert this into power. But the current energy storage system that actually is being used in every satellite is mainly batteries.
uh,
There is
okay.
not that. Yeah, yeah.
Okay, great. We'll just take two more questions maybe.
Sure. Yeah.
So next question is, it looks like people are very interested in this topic. They're like,
Yeah, there are a lot of comments.
yeah, there are like many questions. I don't know how many we can take and how many
Yeah.
in the fixed schedule, but let's take few more questions because for me also these questions are very interesting. So as Anukriti is asking that, as there are many more than one satellite revolving around the earth, is it possible that one satellite signal overlap with another one at receiving point when we receive the signal?
Yes. So satellite signals overlap all the time, and it overlaps with the other signals such as our mobile signals and stuff. So what we do in satellite is we have to talk to our local government agencies. They uh, allow us to use only particular frequencies. So this is something every satellite has to do. It is called frequency allocation. So we have to talk to our government saying that okay, we are going to build this satellite of this size, we are going to use these kind of signals, and we have to make sure that our signals don't overlap with any of the other satellites, and we have to make sure that our signals don't interrupt the mobile network providers. So if you use the same signals, then our your wi-fi or your mobile network will be affected also. That of course is not acceptable, right? So we have to be very careful about what frequency we use, and we have to be in touch with government to do all this administration work.
Okay,
Yeah.
perfect. So let's take one more question. So Aman Kumar, he's asking, hello Aman, he's saying hello. A very
Oh, hello.
informative talk. do solar do solar flares affect the satellite's health or functioning? If yes,
Yeah.
then what
Yeah.
measures are? Yeah, that's a good question because it's away from Earth, so it will go close to Sun sometime during the
So
its orbit. So
So
how?
just to touch about what Aman is asking, he's asking about solar flares. So what I talked about in my last slide is the radiation hardened components, right? I said that there are a lot of plasma and electrically charged particles in the space. So that exactly is, it comes from solar flares. So whenever there is a solar flare, the uh, particles from the sun they travel towards the earth. So these are highly energetic, highly charged particles that hit the satellite surface. So these definitely uh, affect the functionality of a satellite. So let's say any electrical component can be damaged by this because electrical components are affected by electrically charged particles, right? And we are still in the electromagnetic system of the earth. We know that earth has a magnetic field, right? We are Satellites are still in that magnetic field. So the satellite is in the magnetic environment, and if an electrically charged particle hits the satellite, our electronic systems, they can get damaged. A lot of satellites have experienced this in the past, and then the satellite just goes dead. So the measures that taken to protect this is the radiation hardened components. We shield our satellites with a lot of metal, and we calling electrical shielding. And our the printed circuit boards, like the electrical components, are also plated with a lot of different kind of coating, so that these kind of particles are not affecting our systems that much. There is no 100% proofing against these kind of particles yet, but we can do reasonable amount of protection from this in our current technology.
Okay,
Yeah,
perfect. That's a good answer.
yeah.
So we'll take one more question. So it says, Shetong is asking that what are the instrument in the satellite that can allow the satellite to rotate in the space?
Yeah, so this question is something about the control system of the satellite that I only briefly touched about. So there are lots of different instruments. So uh, the rotation, we can have a very basic instrument is called reaction wheels. So what it is, it's basically a wheel. So we rotate the wheel, so the satellite rotates in the opposite direction in order to conserve the momentum. This is the conservation of momentum law from the kinematic laws. So when one wheel is rotating inside in one direction, the outer surface rotates in the other direction to conserve the momentum. So when we want our satellite to rotate in space, we rotate these wheels inside, and the satellite rotates in opposite direction. So we have our calculation that how much force the wheels have to be rotated in and those kind of things. And then we can point the satellites to a certain location on Earth. But there are other kind of instruments also, like there are magnetic instruments which can basically align itself with the Earth's magnetic field. So if we want only a rough rotation, then we can have a magnetic control system which can just align itself with the magnetic field of the Earth, and then we can take the pictures. So
Uh,
that's not very accurate. Yeah,
okay, perfect.
yeah.
One more question we'll take. So, Venkat Reddy is asking that, curious to know how do we remotely control a satellite?
So we don't really actively control a satellite, so to speak, but we only talk to the satellite with the ground station.
Okay,
So because satellite goes away from our view, right? So unless it's a geostationary satellite, the satellite usually in the low Earth orbit or the medium Earth orbit, they go out of our view. So we cannot really be in touch with the satellite all the time. But once it comes in the view, we can talk to the satellite. We can send any kind of commands that it needs to do, or change the program or something. Then it can be controlled in that way, not like active remote control.
okay. So
Yeah,
let me ask you this thing. Can we take few more questions because there are many questions. If you allow me,
yeah,
I can take
sure.
two or three more questions.
Yeah, we can take two or three. Yeah,
Okay,
yeah.
okay, sure. So, uh, Prachi Desai Dahia, she's asking that aren't there any issue of collision of satellite by a meteor?
Yes, yes, there is. But the meteors that we in most of our orbits experience are very small size meteors. So there are constantly monitoring systems which is called meteorite monitoring system. So they have very huge radars on Earth. So they are constantly looking at space, looking at these meteors, and they are constantly mapping if there is any threat to any of the satellites. So if there is a threat to any of the satellites, we will know. But there are some satellites which might not have any way to avoid it. If there is no way to avoid it, we get hit and that's it. But if there is a way to avoid it, we try to avoid it. Let's say we have a propulsion system in our satellite, we can try to use that and maneuver our way out of a collision. But not all satellites have that kind of system.
So there is second last question we are taking. So Smith is asking, can we call GPS also a satellite, as it also revolve around the Earth to track the location?
Yeah, so GPS are satellites. So GPS satellites, it's a global positioning system satellite. So they are satellites just like any other satellites, but their main function is to transmit signals so that we can track our locations. Their functionality is just, they don't do imaging or any other kind of things.
Okay, we'll take just last question. Let me see.
Okay.
So we'll just take, I think it's comment rather than a question. Kumar Mukesh, he's saying very informative and knowledgeable episode. It will be helpful to motivate the student toward the space science. The way of presentation is really wonderful. Thank you so much.
Thank
Okay,
you.
so yeah, I appreciate it. So uh,
Yeah.
before we end the session, I'll just talk a little bit more about, or want to know more about, that if there is any student who want to pursue satellite research or want to make career in this field, what will be your words for them? Like, how they can get into satellite research, or what kind of background you need to get into research, satellite research.
Okay, so I mean, for people who are in India, so it's there is a institute in India called Institute of Space and Technology. It's called IST, Indian Institute of Space and Technology. So it's run by ISRO. So we can students can apply directly to that. That's one way of getting into satellite
So,
industry.
so is that master's program or
There
undergrad
is
program?
undergraduation also. There is undergraduation also.
Okay,
There is masters also. There is research also in that.
okay, okay,
So that admission for that is directly through AI or I don't know what the name currently is, but it is AI or IIT JEE, whatever the name is currently. It's through that.
okay,
So the engineering entrance exam.
okay.
So other than that, if let's say we can satellite work is a multidisciplinary work. So people from all background can be
Part of
uh,
it.
involved in this, even biology. So there is a uh, field of research in satellites called astrobiology. So there are a lot of as one of the viewers also asked, like humans being sent to space and things like that. So people are actually like researching about uh, what happens to human when he goes to space, or how things change. How can we even like, even beyond that, like how can we live in outer space or something like that, the biological needs,
Hmm.
everything. There is a good field of research for astrobiology. So people who are interested in that, it's a very interesting field of research that I don't understand anything about.
Hmm.
So but of course biological people might be very interested in that. And of course electronics and engineering and science, very easy to get into satellite industry, because they can do um, they can get into industry before research, right? They don't really have to do research, but they can still work in satellite industry. Like they can work in some kind of satellite company. So there are a lot of companies in India nowadays. New space is a thing that is very common. New space age labs. There are a lot of people doing many different things. So I
Okay.
would say doing a PhD is not really necessary to get into satellite research. We
Hmm.
can do research after masters or after undergrad. We just have to be in one of those institutes or one of those places to do research.
Okay.
So yeah,
So with that, yeah, I'm very thankful that you provide those information. So would you mind that if you share your email address or something, so that if any student has any question or any they want to
sure.
know anything
Uh,
related to the program, or any further doubt they have, they can email you or something. So if you would like to
I'm
share, or you can
I'm
just
not
say,
sure.
say your email
Did
address.
you get my private chat?
Let me see, comments, private chat. Okay, I got it. So I'll
Yeah,
put it on banner. Okay.
yeah, yeah,
So yeah, so it's any student who have any question or any doubt or related to the program or related to the presentation, related to any curiosity you have, feel free to email. Kashyap, Dr. Kashyap, and let me just put it on the banner so that people can have it. Okay, so now you can tell me like how you like this show. So quickly, I can tell you about this show. That the idea of this show is because after spending a couple of years in abroad, we realized that there is a gap between the real researcher or research we do and the student, because there is not enough exposure in India and many countries for that matter. Like in
yeah,
US,
yeah,
students from 10th class or undergrad, they do real research. They can publish their work. They do hardcore research. But in India, still not many undergrad college has facility to do research.
yeah,
Many students don't have even have exposure. Like when I was doing undergrad, I did not know that what exactly cancer biologists do, or
yeah,
satellite scientists do, or astrophysics do. So like all different fields. So that's what we thought, that let's bring researcher from all different fields and
yeah,
talk about one particular topic every Saturday, and so that the student will get exposure of different fields, whether being from physics, mathematics, physics, sorry, chemistry, bio, or anything related to research, so that they can get inspired, they can learn about those things, and if they like, maybe they can consider becoming a scientist. So,
yeah.
what your thought about it?
Yeah, sure. The one thing I really appreciate you doing this as an initiative, because it is a thing that we need to do, because as you said, even I didn't know much about how to do these things, and because I went out of my country, I was exposed to different things, and it just came in a way that I'm here at this time. But the thing that I have noticed in recent years is like a lot of things are actually happening in India these days.
Yep,
So, like a lot of universities are doing their satellite programs, and few of my friends in India, they have been going around in schools doing outreach so that students of high school or middle school can actually get into this kind of space industry or satellite industry. So they go there and talk about how they can actually become, let's, as you said, like astrophysicist or something similar. So, like, there are a lot of institutes in India, let's say for Indian Institute of Astrophysics or Indian Institute of Meteorology. When we are growing up, we don't even know about these things.
absolutely,
And then we constantly complain that there are not many things in India. But
yep,
there are actually a lot of institutes in India, but it's just a
absolutely.
thing like we only know about it very late.
Yeah, so
So,
that's where the exposure is important. Like once
yeah,
we are in a situation where we know about all these institutes, courses, programs, research, all those kind of things, it's very important to communicate that to the
yeah,
students, so that when they are young, they get exposure of these things, and they
yeah,
can make a wise decision to do
yeah.
what they want to do in their life.
Yeah. So I think this program is very important and very interesting to a lot of people, but very informative to somebody who might get inspired from this. So I urge all people to keep watching Ajit show.
Yeah,
Uh,
thank you. Thank you so much. So, okay,
yeah.
so for for those who came late on the show, so basically this show we call it Science and Research Simplified because we try to put science and research in simple words so that school going student as well as undergraduate student and also the people who is not from science background can learn, can get awareness about different research field. So this show will come every Saturday 7 p.m. Unless if there is any festival or any holidays on the Saturday. So like next Saturday we will not have any show because it's Diwali. But next after that weekend we'll have next show. So there are a couple of very interesting shows which is lined up. Like we are going to talk about cancer. We are going to talk about mechanobiology. There is a scientist from NASA. He's going to talk about more about astrophysics. There are scientists from mathematics. There are researcher who is going to talk about batteries, that what kind of research is being done or conducted in the field of advancement of battery, solar cells. So stay tuned. Come, schedule yourself for 7 p.m. every Saturday. Keep your time slot free for that time and just do watch our show. And if you are watching it after the live show, still you can, post your comments. We'll try to answer them after the live show. And if you're new to this channel, do subscribe to this channel and share with as many as student you can, because from our side we can bring researcher, but it's your responsibility to bring students and share this information to as many as student you can. I think with that, we'll finish or close this session. I think I'm very delighted. I'm very enlightened to have you here. A lot of good information, a lot of good questions, and I wish you all the best for your research. And one
Thank
thing
you.
one thing I want to add here is, I think the satellite you are working on is going to get launched in 2022. Am I right?
Yes, yes. The end of 2021, we will finish our work. The current
Okay.
satellite I'm working on.
Okay.
Yeah. So,
So I'll bring you back after your satellite launches, and we'll have
yeah,
another session with you for
yeah.
sure.
Thank you. Yeah,
Thank you so much, viewers. Appreciate your time. Do subscribe to our channel, and there are many other videos on our channel which is about science experiment. Do watch those videos also, and see you in any on next Saturday 7 p.m. in Indian time, 8:30 at US time. I don't know what time in Singapore.
now it's 11 o'clock.
Okay, so yeah, that time in Singapore. I don't know what time in other part of world. So thank
Yeah.
you so much. Keep watching videos, enjoy, and stay safe, stay healthy. Take care. Bye bye.
Yeah.